In this video, we're going to be looking at how to prove that lines are parallel. So you'll see in the opening exercise, we have two lines, P and S, that are both cut by transversals, and we have the angles marked, and we want to explain why P and S must be parallel. So we don't have to do a formal proof here. Remember, explain means we can just justify our answers. So we're just going to look to fill in any angles that we can. Now, one thing that we might notice right off the bat is that we have this shape in between here with two angles marked. Anytime we see a triangle, we should know that triangles add up to 180 degrees. So, and then because it said explain, I'm going to make sure to write all of those ideas down, whether it's throughout the time I'm doing this or at the end. But since I have those two angles out of the triangle, I can add them together, and it would equal 117. And then I would subtract that from 180, and we'd be left with 63 degrees. Once I am at this point, I can stop finding angles, because you'll notice that 63 in this spot is in between the two lines P and S, and we have the same angle 63 outside, but along the same spot of the transversal. Those are known as corresponding angles. And if we have congruent corresponding angles, that means my lines are parallel. So I know as long as we have one in between these two lines and one outside falling on the same spot along the transversal. So the way I would explain that is that congruent corresponding angles are formed by parallel lines. So anytime we have parallel lines, we would know we have corresponding angles that have to be congruent. So if we can show the corresponding angles are congruent, then my lines have to be parallel. So it's one of the two major ways that we're really going to prove parallel lines throughout this course. The other one is by showing alternate interior angles. And we'll look a little bit more of that in the next example. So if I look at exercise 1, we're given that A is parallel to B. So I have that these two lines are parallel. And I'm also given that B is parallel to C, the lines. And our goal is to show that A is parallel to C. Now, it may be fairly obvious that if two lines are parallel to the same line, then they're probably parallel to each other. But we're going to go ahead and prove that here, so that way we can use that idea throughout the entirety of the course. So it does say prove, so we are going to set our statement and reason up. And we always start with the given information. So A is parallel to B, and B is parallel to C. And remember, the reason is always given. And we're going to look one step further. The first two angles that I would notice that would be helpful for us are angles 1 and angle 2. They're in between these two lines, A and B, and notice that they're both inside the parallel lines, being the interior angles, but they're on the alternate or opposite sides of the transversal. Those are what we're talking about when I was referring to my alternate interior angles. So I can go ahead and say angle 1 is congruent to angle 2 because these parallel lines form congruent alternate interior angles. And remember, as teachers, we really don't care too much about you writing out the words or your spelling. As long as I can understand what you're trying to tell me in the reason, then it's good. So you can abbreviate it as long as I can read that. Now, if I look a little bit closer, I might see the same thing for angles 3 and 4 here. So I could write a third step and say same as reason 2, or I could just squeeze that right into that same step because the reason's going to be the same. I had B and C were parallel, and 3 or 4 are definitely alternate interior angles as well. Now, if I'm trying to prove that A is parallel to C, we're getting closer. And if I look at the transversal that cuts them, I might want to do something about this angle 1 and angle 4. So my goal is to get to angle 1 and angle 4, but we haven't gotten there quite yet. There's one other type of angle that is present in this proof, and you might notice it to be 2 and 3. If I look at those two angles, they are my vertical angles. So I can say angle 2 is congruent to angle 3 because vertical angles are congruent. Now, if I look here, I've gotten really, really close to what we want to show because I want to prove 1 and 4 are congruent. Well, here, since 2 is the same as angle 1 and 3 is the same as angle 4, I can plug those in for one another. And when I plug something in for something else that's equal, that's my substitution property. And luckily for us, because we have 1 and 4, they are another pair of alternate interior angles. So I'm safe to say that A is parallel to C because congruent alternate interior angles are formed by parallel lines. Now that I've shown that A is parallel to C, we can use that every time. If I have 2 parallel lines and then another 2 parallel lines, if they're parallel to the same line, all 3 will still be parallel. There'll be no intersections. Let's use that a little bit further here. Now we can add it into our triangle proofs. So we have the triangles below. We have ACs and DF bisect each other at E, and we'd like to prove that the lines are parallel. So the same idea as what we've done. This is a definition. Parallel lines is just another type of definition. So we really do want to prove the triangles, and then we want to prove something about the triangles to lead us there. So let's think about the types of angles that are formed by parallel lines. One of them could be corresponding, and the other is alternate interior. So I want to look at what I have here. Notice if these are my 2 parallel lines, this would be transversal. So there would be no corresponding that are both in there. Instead, I could have F and D. Those, remember, are alternate interior. One way you can always check to see if you have your alternate interior angle is if it's making a Z, like the other 2 pairs here, A and C. That's one way. So if you see the Z shape going on, it's probably going to be alternate interior angles. So the 2 pairs that I could use are either angle D congruent to angle F or angle A congruent to angle B. Oops, excuse me, not B, C. So if I prove one of those 2 pairs, then I could say that I have parallel lines because I have alternate interior angles that are congruent. But I can't just prove the angles. But remember, we see the shapes. We can prove them by CPCTC. But remember, there's one catch to CPCTC. We can't use it until we prove that the triangles are congruent. Because remember, this stands for corresponding parts of congruent triangles are congruent. So before I prove CPCTC, I want to prove that AED is congruent to triangle CEF. So now we have a little strategy of how we're going to set this proof. So we're going to go ahead and start this. So we're going to have our statement and our reason. Remember, our given in this case was AC and DF bisect each other. So it was the only known information I had. And then I'm going to go to complete this proof. So I have no checks so far. We want 3 checks to prove the triangles. So we have to think about what we know for sure. Well, when I see that word bisect, I know that that's going to cut both of them in half. So I'm going to have DE congruent to EF. And I'm going to have AE congruent to EF. Okay, because bisectors cut in half. I also know anytime I have intersecting lines like this, I have vertical angles. So I'm going to label them 1 and 2 because I definitely can't call it angle E twice because there's too much going on there. If I wanted to label them with the 3 letters like DEF, DEA or CEF, that would be fine. But since I labeled it, this is fine. So we know vertical angles are always congruent. Anytime you see the intersection, we can prove those. And that's my third check. So I can say that triangle AED is congruent to triangle CEF. And the method we have here is side angle side because the angle lodged in between the two sides. But now we can follow up from what we wanted. I could pick either of those pairs or both, depending on which one we wanted to do. Since I wrote D first, I'll just say angle D is congruent to angle F. I could write both again, but I don't really want to just because I don't want you to get in the habit of thinking you need to. So as long as I have one pair of alternate interior angles, then that would be more than enough. Because then I would know the other one would have to be alternate interior as well. And now we wrap this whole thing up because I can say what I'm trying to prove, that AD was parallel to CF or FC, either way, because I showed that we had congruent alternate interior angles and they're formed by parallel lines. Okay. So it's the same concept of what we've been working on in class. If you have 2 triangles, my go-to is to prove those congruent first, then see what we can get out of CP/CTC. Remember, the parts are the angles or the sides, and then use that to lead us into the definition of what we're trying to prove. One other thing we can get from parallel lines is the exterior angle theorem. So that tells us that the angle of an exterior angle of a triangle will always be the sum of the measures of its 2 non-adjacent sides. So what I mean by that is in exercise 3, we're given that ACD is the exterior angle. So that's just the angle outside of the triangle. So exterior inside. We have angles 1 and 2 are the non-adjacent because adjacent means next to. So they're not next to. The angle that's next to it would be 3. And we drew in this auxiliary line. So from time to time, we draw on this line to be helpful to us. So remember, that's possible. We want to explain why the measure of angle 1 plus angle 2 must be equal to ACD. To look at this, there's 2 things that we know for sure. If I'm just thinking about what we know, I know triangles equal 180 degrees. So that means angle 1 plus angle 2 plus angle 3 equal 180 degrees. And I also know that angles on a line add 280 degrees. So I know angle 3 plus angle 4 plus angle 5 is equal to 180 degrees. So I have this set. So if I'm looking at these 2, I can kind of see these 2 equal to each other because I know they both equal 180 degrees. And I can kind of cross out angle 3 because angle 3 is in both of them. So I don't need that. And I want to think here, I know that angle 1 is congruent to angle 4 because I drew in a parallel line. So those are my alternate interior angles. So I know 1 and 4 are equal. And I also know that 2 and 5 are equal because those are corresponding angles. So if I know those 2 pairs are equal, notice 1 and 2 made up the remainder of the triangle, while 4 and 5 made up the outside piece. The exterior angle is always equal to the 2 inside.